we want to thank you guys for taking time out of your busy schedules to join us on our monthly Knowing and Ask workshop. I think they have been good so far. We've been doing them now for a couple of months. The series that we're doing now is in the air. I'm not really sure what we're doing next month, but so we do appreciate you guys joining us. This is part of the Eastern Service Center initiatives. My name is Angela Smith, and I'm a champion for the initiatives. And my peer here, Kevin, is the initiatives to lead. And you know, if you guys have any questions about the initiatives, and you know, please join us every month. We appreciate it. This month we have Bruce Williams here. He's going to talk to us a little bit about Spectrum, and if you guys have any questions. Also remember that if you have people who could not make it today, we do post the workshop. He's filming it in the back, and we'll post it on the KSN when we send out a questionnaire, how you guys appreciated or what you liked or didn't like about the workshop. So feel free to pass that along. There is a sheet, like Kevin said, that's floating around. Please sign that so we can send you a personal thank you afterwards. But Bruce, if you're ready.
All right. Thank you, Angela. I appreciate it. I do have a couple of sheets I'm going to pass out and get others' presentation. So, good morning. My name is Bruce Williams, for those of you who don't know me. And I work in spectrum management, frequency management, HAW1 Charlie 1C5. We are broken up into, essentially we have headquarters, and we're broken up into 3 service areas: Eastern Service Area, Central Service Area, and Western Service Area. Spectrum management, or spectrum assignment and engineering office, carries out those spectrum engineering functions that are day-to-day operation of our national radio system, and acquiring National Telecommunications and Information Administration authorization to radiate on a specified frequency at a designated location for each of the communications, navigation, and radar facilities operated by the agency. The office is also responsible for continuing the development and the operation of the automated frequency management system, the airspace analysis model, which is the AFM, and for managing the radio frequency interference program. This is just a picture of our Charleston remote communications air-to-ground facility. This facility is a comm facility that talks to the center. This particular facility is in Charleston, South Carolina, and it serves the Jacksonville Center. So controllers are keying their mics, and they're talking from this facility out into the airspace. This is the Jacksonville ASR-9, which is just a radar. This provides radar coverage for Jacksonville air traffic control and a couple of other users or customers in the Jacksonville area. This particular radar has, of course, channel A and channel B, and of course it's located right on the airport there at Jacksonville Airport. This is Sanford RTR, which happens to be housed on the top of the Sanford air traffic control tower. This is our transmitter site and receiver site on top of the facility there. And this is a glide slope out in Oklahoma City, which is, of course, is a nav aid. Now, Spectrum assigns frequencies, engineering, we assign frequencies for all of those disciplines: communications, radar, and also nav aids. The Spectrum Engineering and Policy Office secures, manages, and protects all civil aviation frequency spectrum resources. The order in which we do all of our work is 6050.32b. Spectrum engineering serves as a principal element of the FAA with respect to discharging the FAA responsibilities in the management of the RF spectrum. We plan, direct, manage, and evaluate the agency's spectrum programs and projects. We provide policy, technical guidance, and evaluations to the agency. We direct by coordinating and negotiating with other governmental agencies, industry, and even international partners to obtain appropriate spectrum resources. Spectrum also establishes and issues policy regarding radio frequency allocations and regulations governing the use of civil aviation spectrum policies. Spectrum engineering also represents the FAA before all national organizations involved in various aspects of the managing the spectrum. We engineer transmitting and receiving frequencies for all aviation users of the NAS frequency bands, assuring the most effective and efficient spectrum use, including firefighting frequencies in the event that there's a fire. We serve as a focal point with all within the FAA for all spectrum matters. Spectrum also engineers frequencies properly according to the formal assignment with respect to radiation, propagation, emissions, and power factors, including consideration of protection from potential interference. We're going to get into that a little bit. All frequency assignments are documented and filed in the GMF, or the Government Master File. Periodically, we conduct frequency audits at en route and selected tower and TRACON facilities with invited lines of business, including planning and requirements, P&R, TSOG, Tech Ops, and also OS&G and air traffic. An FTA, or a frequency transmitting authorization, is provided for each emitter to be physically posted at the facility, signifying the license for that emission, or for that emitter. So each FAA facility has an FTA. That's the license. The last thing that we do is we investigate and we mitigate radio frequency interference problems in the NAS. That's what an FTA looks like. It's not a real clear picture, so what I chose to do was make some copies so that you can see what an FTA looks like. I didn't bring a whole lot of copies, so. But if you would, maybe one table of each, you pass those around. So you can take a look and see, this is the license that every FAA facility will have, signifying each frequency, its usage, its emission, and essentially that facility, the facility that it's tied to, its facility ID. In this particular case, I believe this is QRP. You'll be able to see this in a second when those pass around. This is Mount Oglethorpe, which is a remote communications air-to-ground facility located at Mount Oglethorpe in North Georgia, which is about 10 miles east of Jasper, Georgia. That RCAG happens to be one of the busiest facilities in the NAS in terms of clicks by air traffic control. And one of those frequencies in particular is 133.1. And is that list getting around? Do we have enough? Spectrum guys, you won't need one of those. So this FTA must be, this is our license, and so when guys from our technical inspection group or the inspection group come out, they will come out and they will survey this FTA to make sure that all of the documentation in this FTA is correct. And if it's not, then the facility will be checked off as, or been given the responsibility of correcting it. So this is a way of self-checking ourselves to make sure that what we are transmitting is licensed in our government master file, in our database. If it's not, then we need to correct it. In some cases, these FTAs become very old, they become withered, and they need to be replaced. In some cases, we will have a facility, or we'll have engineering services come out, and they may move a facility and neglect to let us know until someone comes along and notices that the lat long, which is here, is not correct for the facility, and they'll note that that is the case, and then eventually what happens is someone will come back to Spectrum and say, okay, we need to get this corrected. Well, once it's moved, it has to be re-engineered. And when it's re-engineered, in some cases, the frequency may change, or the frequency may be denied, depending on the situation. This is a depiction of our VHF band. I'm focusing a little bit today on communications because communications is probably the most vigorous of our groups amongst comm, radar, and nav aids. If you notice within the spectrum band, the resource from 108 to 118 is VORs, ILS, and then of course 118 through 136 is all comm. Not all of that comm belongs to us. We own 118 to approximately halfway to 122 or to up to 122, and then there are other users between 124 and approximately 126, and then we pick up the band again around 129, and from there 129 to 132 belongs to a group called AirRink or ASRIC. From 129 to 132 is utilized by commercial users, airlines, FBOs, and so on and so forth. So you see, we don't own the entire band. Then from 132 up to 136, we are now users again, we being the FAA. Notice that there's 760 channels between 108 and 136, but there's only 535 channels available for air traffic control. And that is because, of course, spacing. We will get into that in just a second. This is another depiction of the stratification between 118 and 136. And as you can see, again, the FAA is not, I guess you would say, we don't own the entire band. In other words, there are other users within this band. Notice that 121.5 is our ELT, or emergency frequency. 121.95 is aviation support. 122.0 to 122.05 is EFOS, or en route flight advisory system. 122.85 is multicom. Most of you know that AVN, or Flight Standards, supports us in the air. They have two frequencies, which would be 135.975 and 135.875. So those two frequencies are used exclusively by Flight Standards in the air. So when they are evaluating our nav aids, yes?
I just had a question on this authorization. This is like our plan, but FCC signs off on it, or?
No, sir. That is completely us. We, let me go back a second. That's a very, very good question. We own this band from 118 to 136. We are the caretakers in red. We are the caretakers. We are the license. We do the engineering, the FAA, strictly. So as you can see, even from 118 to 136, we don't own the entire band. We have to have 25 kilohertz of spacing from one frequency to the next. And these frequencies are highly sought after. They're very, very expensive. They're very, very precious. It's a very, very precious resource. As you can see over the years, we've had a lot of growth with regard or with respect to frequency assignments, and the numbers keep going off the charts. This is a depiction of the density of all of the comm assignments within the NAS. And as you can see, places like Miami and Atlanta, LA, New York are just one big blob of assignments. Their question is often raised, especially with regard to Sun and Fun and some other events like Masters. Why can't you guys just assign frequencies for the entire year and just let us keep them for the entire year? Well, if you're going to use a set of frequencies for 2 weeks, we just simply cannot afford to assign, static frequencies for a particular location. So if you'll notice in Central Florida, again, it's just one big blob of frequencies. We cannot afford to assign 8 or 9 frequencies for Sun and Fun to sit 50 weeks out of the year, or Masters for 51 weeks out of the year. it's just too valuable a resource. It's almost like saying you're going to sit, your favorite meal for a couple of weeks out and you're just going to let it sit there. I mean, eventually you're going to want to eat it. Otherwise it'll perish. So you see the density, it's only getting tighter. It's a real challenge in terms of engineering and addressing air traffic's needs, because as you know, air traffic's requirements are growing even more and more. Charlotte is getting a new runway soon. There's talk of a runway 6 here in Atlanta. And with those new runways come requirements: approach, departure, ground, and in some cases maybe even a gate hold frequency. So as the requirements increase, our challenge in spectrum gets that much more demanding. So we have to be really, really good stewards of the entire spectrum band. Sometimes we simply have to say no, when we really don't want to say no. There's 3 criteria in the comm engineering phase that we'll look at today. One of them, of course, is co-channel, and we'll get into that a little in depth. Adjacent channel, and the last one is intermodulation. As I mentioned a little earlier, channel spacing is 25 kilohertz from frequency to frequency. That's the letter of the law here in the United States for now. In the future, we may end up going to 8.33 spacing, because why? Because we're running out of frequencies. The fact of the matter is, there used to be a time that you could dial someone up in your hometown with 4 digits. I don't know if there's anybody in here old enough to remember that. Okay, so I'm pretty old then. Okay. And then it was 7 digits. And now it's 10 digits or something. Right? And the reason why is because we're running out of numbers. The iterations, we're running out. So what we've done in the last 25 years is we've gone from 50 kilohertz spacing, 121.1, 121.15, 121.2, to 121.0, 121.025, 121.050. So we're tightening the band. We're spreading out the resource. Yes, sir.
The receivers that would be needed for that would be a whole new, it would take a lot of that to be able to do.
You're right. That's a very, very good point. And what he's pointing out is that as these requirements change, we are requiring the entire aviation community to adjust or to make that change equipment-wise. And that requires not only a lot of agreement amongst the entire world. We're not just talking about the FAA, we're talking about the entire world, but we're also talking about agreements with regard to money. Now, the good news is Britain and Europe, they're already at 8.33 spacing. And a lot of the overseas flights that come here, the 767, the 747, the 777, they're already equipped to 8.33 spacing because they travel internationally. We're not there yet, and when we get there, it will require accommodating that band or those frequencies with equipment, and that calls for money. If you think about the Malaysian...
On the current radios, would there be bleed over if you use the current
There would
radio?
be a greater preponderance of bleed over, or a greater opportunity for bleed over, yes.
Okay.
Because now you're narrowing your bandwidth even more. So if you have adjacent channel noise, you have a greater chance of that noise occurring. But yeah, you would have a greater chance for interference, that's true.
Right.
Yeah, you're slicing that pie thinner and thinner. So now instead of getting a big wedge, you're getting a narrower wedge pie. Years ago, the requirement was to go down to 25 kilohertz. I remember when I started in this job like a whole long time ago, 20 some odd years ago, we had requests from some flyers to give them a specific frequency because their radios did not dial down to 25 kilohertz. Well, the answer to that is either buy a radio that is compatible or stop flying. Co-channel interference, the separation distance between the designated operational coverage area of two facilities operating on the same frequency shall be greater than the sum of the different distances to the radio horizon for each facility. I know that looks crazy, and I'll try to show you a little bit of a pictorial here in a second. Just a couple of things to bear in mind. There's two ways to create silence. One of them is space, and one of them is radial line of sight, or the Earth's curvature. If you want to get away from somebody that just gets on your nerves, then you move away from that person. Well, that's the same concept that we have as we assign frequencies. In other words, in order for me to be able to reuse a frequency, I have to create space. So ICAO, the International Civil Aviation Organization, requires 14 dB of signal to noise from frequency to frequency as the aircraft are flying through the airspace. The other thing, of course, is line of sight, or curvature of the Earth. So at some point, if one aircraft is here and another one is out here, the fact of the matter is the curvature of the Earth will literally retard the signal from getting to the next aircraft. So those are the two things, or the two attenuators, that we count on when we assign frequencies for co-channel. Just for a note, at flight level of 35,000 feet, radial line of sight, let me see if I can draw this up so you can see it. If an aircraft is at 35,000 feet, flight level 350, they're flying along, the torque down, or the RLOS, is 264 miles, nautical miles. So, as this aircraft transmits as it's flying through the airspace, that signal will actually travel 264 miles. So that is a criteria that we have to account for when we assign frequencies. And a lot of people say, again, well, why can't you just assign this frequency or that frequency? Well, again, we are stewards of the band. Here's an illustration of a little bit of what I'm talking about. And it's real simple, even though it looks a little crazy. If you have a facility here, the very next facility with the same frequency, this distance from here to here, same frequency, next facility, that distance is equal to this distance plus this distance plus this distance plus that distance. It's really that simple, but it's not that simple. In other words, the distance from the aircraft to the facility plus the distance, the RLOS, in other words, this torque down to the horizon, those are added for this aircraft plus for this aircraft, and that equals the distance that I can assign another frequency. So in other words, the higher that we use a frequency, the less that we can use that reuse that frequency throughout the NAS. And there's an illustration.
Was that the case of a COM, or is that a NAVI?
This is COM. Yes. So at flight level 350, I can only reallocate or reassign the same frequency 5 times throughout the nation. 5 times. That's it. And that's at flight level 350. Mind you, our traffic control is now talking up to 41, flight level 410, 420. So needless to say, I may only be able to assign 4 times because of RLOS. This is an illustration of frequency 121.125. I think it's 121.125. It's at BKQ. It's at Brunswick, and it's also at Charleston, and it serves this sector, ZJX 51. That frequency is used you'll notice is used at Brunswick and is used at Charleston, and I'm going to explain to you in a little while why we're able to use it so close together. It's used up here, which is in Illinois, I believe. It's used out here in Paso Robles, California, up in Portland, Oregon, down in Texas, and over here in North Little Rock, and that's it. That's it. Why can't I use that frequency more? Now, some people may say, well, but wait a minute. You use 21.9 in a lot of airports. Yes, because 21.9 is used on the ground. So your RLOS is literally nothing.
When you do that plan, because I still actively fly a lot of the Unicom and CTAF frequencies, there's a lot of bleed over.
Okay, that's a good question, and I'll tell you why. Because there's no rules with Unicoms and CTAFs. It catch can. The rule says there is no interference. There's no rules.
So they're planning on putting a few more frequencies designated.
That's another very, very good question. We have been encouraging the flying public to go out and seek out the FCC, because this is a non-fed. We're asking about a non-fed, by the way. That is a non-fed, and the public would have to go out, the flying public would have to go out and engage for a frequency such as that. They may eventually reach out to the FCC, and the FCC may eventually reach out to Paula, but eventually that is a non-fed. There's no resolution of interference in that case. It's almost like a shop line, if anybody's old enough to remember.
So you guys are not really interested in that need at this point, but
well, the military is, my good friend John Love in the back can tell you, one of my coworkers, he can tell you that the military has expressed some interest. What's happening down in South Georgia and North Florida and South Central Alabama is that we're getting more and more helicopter aviation training, which is good news, because what that means to me is that the economy is booming. So we're seeing more and more vigorous training of helicopter pilots. Well, those helicopter pilots use the CTAFs. They use those frequencies.
or clip the 5-finger freak.
That's right. And so what's happening is that when they get on that frequency, there's 12 other people trying to talk on the same frequency. And so you literally have to wait your turn until you can communicate what you want to communicate to your environment.
Right.
So, co-channel. In this particular case, this frequency is at flight level 410. It serves ZJX51. I'm going to get into this a little bit more in a second. But the point is that I can only reuse this frequency approximately 1, 2, 3, 4, 5 times throughout the NAS. And that's it. So that frequency's done. And this is a challenge for us in the NAS. Adjacent channel interference. The criteria is from 25 kilohertz to 25 kilohertz. I need 7,000 feet of separation from aircraft to aircraft. And I need about a little more than a half mile in distance, again, from 25 kilohertz from 133.275 to 133.3. This is a challenge for Paula oftentimes when she's assigning frequencies in the terminal environment, RTRs. And this the second criteria that one must meet in order to assign or engineer frequencies. Intermodulation is our third criteria. It's a form of co-site interference resulting from the mixing of two or more co-site transmitters which, when added or subtracted from one another in some sequence, produces a resultant frequency equal to or being received elsewhere at the site. And this is just a very simple example. When you double 121.9, which in most cases is ground frequency, and it mixes with a radio station, which is probably maybe only 5 miles away, that forms the frequency 135.9. So from time to time, you may hear someone say, I'm getting interference on 35.9, and I think I hear I think sometimes I hear air traffic control, but then other times I hear, I'm hearing Paula Abdul or Beyonce. Okay. And then sometimes I'm hearing James Brown. And then sometimes I'm hearing Mahalia Jackson. And then sometimes I'm hearing, I don't know, Coldplay. So, and Intermod acts like that because 107.9 is a emitter that's on all the time. FM, it's on all the time. 21.9 is on when it's keyed, and the second harmonic mixing with the FM lands on 35.9. Now, the way that we fixed this issue is kind of simple with the newer radio. Some of you know that we now have a newer generation of transmitter and receiver. And that newer generation of receiver or transmitter in this case, has built in a second harmonic filter. So the second harmonic of when that controller keys that mic, the second harmonic of 21.9, I don't know where it is, but the second harmonic of 21.9 is now attenuated or beat down, literally, so that this does not occur. Okay. When engineering frequencies, the FMO has to take into account numerous frequencies outside of our allotted band, like FM, but potential mathematical contributors to interference due to proximity, power, and position, like FM. And in some cases, the FM is not legal FM, it's illegal FM, as some of you know. Or AirRink. AirRink, by the way, is a very powerful player around the airport. They provide aviation services for every airline, or for the airlines that actually engage them. And so when AirRink positions their transmitters around the airport, they don't play by the rules as we do. It's catch as catch can. It's whatever's available. And so oftentimes it's a challenge mitigating interference with regard to AirRink. So it's a bit of a challenge. ESA frequency management offices here in Atlanta and also in Nashville perform or assist in the detailed on-site investigations needed to resolve radio frequency interference. These investigations are initiated by a Code 84 in Naples, as my good buddy in the back knows. The investigations are generally conducted after or in conjunction with Technical Support Operations Group, TSOG, and technicians or other personnel in the field. In some cases, the investigations are aided by flight standards or the flight check group. There are a few cases where flight check will actually take us up and seek for the interference in the air. Oftentimes it takes that, because when air traffic reports an interference problem that a pilot is experiencing, we have no one on the ground that can hear that. Remember the concept about RLOS. Let's go back to that for a second. A pilot could be at flight level 350 and experience interference literally over Tampa, Florida. Tampa, over here on the west side of Florida. And the interferer literally could be over here in Jacksonville. Why? Because the pilot is at flight level 350. And so the signal, RLOS-wise, can impose upon this aircraft because the aircraft is so far up in the air. So although the interferer is down here, or although the aircraft is here, the interferer is literally over here. So if you investigate the interference problem below the aircraft, let's say below Tampa on the ground, you may be looking forever and never find the problem because the problem is over here in Jacksonville. So in cases like that where it takes forever to find the problem, we just call up flight check and they take us out up in the air and we actually seek for it. If the RFI cases have the potential or do involve the public domain, the FCC is requested, and in some cases they're required. Remember, we don't own the whole band. So if the interference is outside of our band, or the source of the problem is coming from a place outside of the band, then the FCC gets involved. Or if the interference is coming out of your house, any one of you, then we get the FCC involved because you're public. You're now a public person. You're not FAA. Spectrum also identifies and we test and procure RFI equipment used by TechOps, AVN, and TSOC personnel throughout the ESA. And with the help of some people that I see here, right in here in this room, they've been very good about helping us to procure that equipment because we don't have a real machine to procure equipment. Investigating RFIs sometimes involves the DoD. We do resolve some DoD or military facilities or installations. We also get involved with NDAG and other governmental agencies, including ASRI and ARRAM. And as I mentioned before, ASRI is the Aviation Spectrum Resources, Inc. They manage and coordinate radio communications licensing for the aviation industry in the United States. There's three types of interference that we look at. One of them is intentional radiators. That's a device that intentionally generates and emits radio frequency energy by radiation or induction. For an example, a garage door opener or a transmitter or a cordless phone or a uni device. And then there's incidental radiators, devices that generate radio frequency energy during the course of its operation, although the device is not intentionally designed to generate or emit radio frequencies. And a good example of that is power lines. We have a lot of problems with power lines, but also mechanical switches and motors and so on and so forth. Here's an example of an intentional radiator or a transmitter. That would be an unlicensed National Infrastructure Information Device, a UNI. Yes, sir.
Can you go back to the last slide?
Sure.
On the intentional radiators, can you expand on items that are purchased out of China that don't have that FCC standpoint?
That's a good question. There are a lot of devices that are available to you today, especially via the internet, that are not vetted by the Federal Communications Commission. Those devices are, in some cases, are made in China or some other places. Some of those devices, some of them are cheap. Some of those devices are poorly engineered. And because they're cheap and they're poorly engineered, we like them. The problem is that those devices oftentimes will transmit incidental or even intentional, but sometimes incidental interference.
Is it the fact that they don't have enough shielding, or too
In
much
some cases,
power?
in some cases it's shielding, in some cases just simply engineering.
Pushing too much power?
Or too much power, that's correct.
Another issue is that those frequencies that they operate off of don't correspond with the frequency that we use here in the United States.
Yeah, that's true. In some cases, they literally take that band that we just talked about. I don't have that in my PowerPoint, but I can show you, I think I can draw it out for you. There's many years ago, down in Miami, we found high-powered, cordless, long-range phones that you talk on. And these phones were wireless, and they were high-powered. But these phones also were literally designed to transmit in the aviation band, made in China. So literally, you're sitting there at, say, Miami Center, and you're listening to the air traffic controller, and all of a sudden somebody's calling, and they're calling to make an appointment to see the doctor. Conversation.
Right.
So, and in this particular case, the company's name was Baotong, I believe. They're made in China. You can get these devices, by the way, on www.alibaba.com if you want to buy some of this stuff. But they literally were designed to transmit between 134 and 135.
Yeah, when you pay for it, they give your credit card number to everybody in China.
Let's go back for a second here, just so you'll see what I mean here. Remember, we own this, between here and here, we own that. Remember, that's the FAA. Nobody else but us, right? But the Chinese decided, we're gonna design phones, high-powered phones, that transmit between 134 and 135. Now, you know, the first time we discovered this, we were like, what? Are you kidding? And then we found another phone, and then we found another phone, and then we found a store in Miami that was marketing these things.
Well, they needed it.
And we didn't wear the badges, and we, inquired about buying a couple of them, and we did buy one undercover, and sent it up to Atlantic City for it to be evaluated. We actually contacted the Chinese as well, and the Chinese told us to go stuff it. That's right. So, that's a good question. That's a problem. That is a problem.
So what was the answer to that? I mean, are they still, that's their done so?
Yes, stuff it.
And
Now, we finding cameras made like that. Cameras, we found a camera in Alabama a couple of years ago, Charles and I, that was transmitting around 1,000, between 900 and 1,000 megahertz. Camera.
What band? What band was it playing?
That's a nav aid band. And GPS. And GPS. Now that's what we're supposed to be relying on at one point, aren't we? Really soon? Aren't we supposed to be relying? You guys have been out, I'm sure you've been out. Oh, I need to find that grocery store that somebody was telling me about. All of a sudden, what's wrong with my phone? Why can't I find, what's wrong? It's buffering. Well, believe it or not, there are GPS jammers out there. We found two GPS jammers 2 years ago in Miami. Not very, very far from the center. This gentleman apparently didn't want his boss to know what he did during lunch. And so he decided to go out and buy 2 GPS jammers and install them inside of his work vehicle. Not a vehicle that he owned, but a vehicle that belonged to the company. He was delivering gas containers. LP, gas. And these jammers wiped out the GPS band, the comm band, the nav band, the cellular band, I mean everything. That's a problem. And so your question, I think, was what do you do about that? All we can do is case by case is resolve it. We have no
I'm sure you found it.
power.
You're talking about it because you found the guy.
Right.
Yeah.
And I think his boss relieved him of his job.
That-
Yeah.
I mean, where would you go to purchase something? I mean, that's.
www.
Yeah, I can't believe that.
To be honest with you, I don't really want to get into it, but I can talk about it a little bit, but no. Well, the FCC, at this point, if some of you may know, they are actually reducing their staff that handles these cases. They're in the process of reducing the staff that handles these types of cases. Yeah. So the answer to your question is very, very little. On a case-by-case basis, what we are required to do is to eliminate the interference. But in terms of the FCC having a lot of power, the answer is not really. Even with Pirate FM, we really have very, very little power and very little power, at least the FCC has very little power. Only when it's safety of life are they able to actually go in and get an affidavit, get a court order, and get a seizure. Yes.
Go back to the camera for a second. What are you saying, like video camera? What kind of camera?
Video cameras, mostly video cameras.
Okay.
Yes, mostly video cameras. You're gonna see one. It's not the most prevalent one, but I didn't put a lot of juicy stuff in here. I don't know if you guys will stay awake. But yeah, so the answer to your question is it's getting worse, and Congress has decided to reduce the FCC's staff the folks that actually handle enforcement. There's an enforcement group. That group is being reduced. The Miami staff is being dropped from 3 to 2. Tampa's office, 7 people, is being closed. The New Orleans office has gone from 2 to 1 person. The Virginia office is being closed, and so is the Philly office being closed. So
It's your
they're
opinion.
reducing staff.
Your opinion, that's dangerous, what they're doing.
Yes, I would say so. Yes, Mr. Love.
Let me add a little bit to that if you
Sure.
don't mind. Main reason that those offices have been reduced in staff is a commerce issue. A lot of the bands are being sold off to commercial entities. Cell phones, things of that nature, that's money, because when you start looking at the different types of systems that they're putting in, they require more frequencies to give you more bandwidth for data. Okay. The other piece to that is, if you're going to buy any type of electronic that's an emitter, or you believe might be emitter, make sure it has that FCC stamp on it, so you don't have any.
And even check the stamp, because we've even found bootleg stamps. They look like FCC stamps, but they really weren't FCC stamps. Now, I can tell you now, Walmart sells LED lamps right now that interfere with our facilities. Walmart. In fact, I've got one up at my desk. I should have brought those lights. But LEDs are really giving us a lot of problems as well.
It's some sort of intermod though, it's not deliberate, right, on the LEDs?
Yeah, that would be considered incidental. In other words, a device that generates enough energy to overload or overwhelm your receiver. It's not intentional, but it's incidental. Now, that we do have intentional interference, as you can see here, intentional in the sense that I intended to transmit in the band. Not intentional in the sense that I intended to interfere with the FAA. That would be something different. And that happens too, occasionally. So, question? So, intentional radiators, UNIs. UNIs is just a fancy name for broadband throughput. And this was a real problem for us about 4 or 5, well, actually 8 or 9 years ago now.
Is that up there intentionally?
We had interference, particularly in the big cities like Miami, New York, San Juan. San Juan is still being hammered by UNII interference. UNIs are very convenient because it doesn't take a lot to install one, a Cat 5 cable, some power, and throughput, and boom, you're there. And now you've got all kinds of throughput. The problem is that when UNIs were vetted, they weren't vetted very well. Somebody took somebody to dinner, and the next thing you knew, the vetting process was lukewarm or watered down. And what I mean by that is that the frequencies that UNIs transmit on are literally in the TDWR band, the Terminal Doppler Weather Radar band, which provides air traffic with information about wind shear and downdrafts, which is kind of important. So as you can see, we trace UNIs all over the place: San Juan, Miami, Tampa, and even New York. You see here Charles Thornton, literally on top of the Empire State Building. We found quite a bit of interference up there. Yes, Charles?
I do want to point out I have lost 15 pounds since I've been
What are you talking? This is what a uni interference looks like, okay, for the Terminal Doppler Weather Radar. And the problem is not so much just the bands, but the problem is that within these bands, your weather products information is now being compromised. The physicists and the weather folks say, I don't like that, I don't want that, and that will now negatively impact air traffic's ability to determine whether or not I have this aircraft take off or not, or land or not. Remember Delta flight, what was it? Oh boy, I can't remember the name of the flight.
Whatever.
Remember the Delta flight from about 25, 30 years ago?
Into Dallas?
It flew into Dallas? Yes. The L-1011.
The wind shear.
That it was wind shear, downdrafts. At the time, There were some who said, oh, downdraft can't take an airplane down. Well, that one did. That airplane came down and split in half. The smoking section survived and everyone else perished. And believe it or not, Delta sued the FAA. Yeah, they did. And the Supreme Court came back and said, oh, no, Delta. Ultimately, the responsibility was upon the captain of that ship to determine whether or not to land or not. What Delta was arguing was, we don't have enough good weather information around DFW. Well, even though we won the lawsuit, Congress came back and said, look, FAA, we're going to give you $300 million. Because now we believe the scientists when they say that a downdraft or an updraft can actually take an aircraft down.
I can tell you after that crash, all the crews all over were taught low-level wind shear, what to look for, because it sets you up for failure. I mean,
That's right.
It's giving you, you're getting a headwind and everything is, you're getting above your course, all of a sudden you're adjusting to, and all of a sudden the bottom hits out and it's slamming you towards the ground.
That's right.
It's really insidious.
That's right. So approximately 53 major cities, not every city, but the major airports where we have those weather conditions, because I know some may say, well, Bruce, Los Angeles doesn't have a TDWI. Well, that's right, because they don't have these kinds of weather conditions. But you best believe Miami does, and so does Orlando and Atlanta and San Juan. And so this was a big deal about 8 years ago. And the FAA literally stopped the entire world from making units for a while. For a while. They stopped the manufacturing of these things called UNI devices. There's a lot of politics behind units because remember, around 2005 or 6, during the Clinton administration, or 94, 95, 96, during the Clinton administration, something called the internet really took off. And unis pushed the internet, throughput, commerce, money. This is a depiction of interference on the ASR-9. Remember we saw the ASR-9 at Jacksonville a little bit earlier. This is some interference that we had there off into the east. After almost 2 years of investigation, somehow we got lucky and saw this little signal. It didn't look like very much, does it? Doesn't look like much, but believe it or not, that little signal is causing that. And that became a real distraction for air traffic in Jacksonville. This is only on channel B, by the way. And if you notice, it's at exactly 2745. And what was causing that? Well, what was causing that was this. This particular just one card reader happened to be 1 mile positioned in front of the radar, and it just happened to be at 915 megahertz. And the third harmonic of 915 is 2745. You talk about a perfect storm. How could that be? Incidental radiators. Just about a month and a half ago in cold Asheville, North Carolina, we were getting interference all over the UHF band, as you can see off to your right, all over the place, just like a real loud noise. And what in the world could that have been? It turned out to be these air conditioner chillers. One of them had a fuel leak or a freon leak, and as it would try to compensate for the freon leak, it would crank on and crank off and crank on and crank off. And every time it cranked on and cranked off, this is what we got on our UHF, in the UHF band. Air traffic was tired of it, just sick of it. This is probably one of the most common problems that we have in the FAA because remember we're in the AM band and we have a lot of our RTRs that are located around power lines. This is another example of incidental radiators, and it's probably the most common one, and that's power line noise. These are meters up here at MCO, and lightning struck one of them, and we got all kinds of noise here. Now, this noise, as you'll notice, is very, very broad, The problem with this type of noise is that it wipes out the entire spectrum. So when this happens, and when this did happen in Orlando back in 2001, by the way, this happened right after 9/11, completely freaked out all the controllers because everybody was nervous at the time. This wiped out all of the frequencies, and they threatened to close the airport.
So when something like a power line is going up, there's no submission of a obstruction evaluation that you all provide input on?
Not at 60 feet, no. Not on a, because they have, the easements belong to power companies and the local municipality. That's a good question, though. What we try to do is when we plan for the future, is we either request or try to obtain underground power service, or we try to make sure that we distance our receivers away from the power lines. That's a good question.
How far is that problem from MCO?
It was about 300, maybe 400 feet.
Okay.
Yeah, and you know, again, if you're going to close MCO, that doesn't go over very, very well. No. Last year, we lost the entire Palm Beach rag site. The entire rag site. This is remote communications air-to-ground facility serving Miami. We lost the entire site. And when I got down to Palm Beach, I started creeping around the guy's house and I saw this signal. What is this? You know? And if you'll notice, it's from 113 all the way to 163. That's beyond the band. That's everywhere. Once again, incidental radiator. What we found inside of this gentleman's roof was a Remy air purifier that he didn't want to turn on. And that wiped out the entire rag site. Now, that's several sectors feeding back to Miami Center. Now, as most of you know, we do have Buicks, but if you lose the Buick, and guess what we did? When you lose the Buick, now we have problems. Spurious emissions of a frequency or frequencies which are outside the necessary bandwidth and a level which may be reduced without affecting the corresponding transmission of information. Spurious emissions include harmonic emissions, parasitic emissions, intermodic frequency conversion products, but exclude out-of-band emissions. Camera, do you see any? Well, yeah, there's one right there. And it belongs to Homeland Security. This is in Miami, by the way. This is affecting the VKZ, which is Virginia Key, which is in Key Biscayne, DME, distance measuring equipment, located at the VOR at Virginia Key, 5 miles away. There's the camera. There are the emitters. See the little antennas? And there are the bootleg signals. When we popped this open, we found Chinese transmitters.
What kind of equipment are you just driving around town with?
Good question. This one was a headache. It was also hilarious and entertaining. We were literally building to building with a horn and a spectrum analyzer. This one we found the old-fashioned way. It's almost like making a cake with flour and sugar and shortening, milk and whatever. This was literally with a horn antenna and a spectrum analyzer and walking all over, literally.
And that, where was that at? I was on Miami.
This
Airport?
is Venetian Bridge, if anybody's familiar with Miami, South Beach. Yeah, it's north of where all the action is, but it's Venetian Bridge. It's a little north of, if anybody's familiar with South Beach, a little north of where the action is. approximately 5 miles from Virginia Key. Belonged to Homeland Security, talked to Homeland Security. They went to a third party to install these, and that's where the issue came in with the third party. You guys have had work done in your house, you know how it goes. Last fall, Palm Beach again, air traffic control this time, RTR this time, local approach frequencies wiped out. Sometimes it's just noise, sometimes the pilots are hearing radio stations, sometimes it's just buzz. This went on for a couple of weeks. Finally, we got fortunate, was able to beg Flight Check to come down. He took me up, and immediately as we got up there, we began to see these signals. Notice that this interference was all throughout the band as well. And when we got up into Stewart, Florida, we discovered a cell tower. But look what's on the top of the cell tower. Well, there's a 2-bank FM transmit antenna. This is a radio station. And the radio station's coax had a hole in it and it had gotten water in it. So the visuals were completely off the charts and the transmitter was pretty much toast. So we were getting that signal all day long, 7 days a week, 24 hours. And that, you know, typically when we get to a site, air traffic is livid. You know, they're not in a good mood.
So in a case like this, you go there and you say, hey, fix your transmitter, or you?
Oh, now in this case, I call the FCC, because remember, this is the public.
Right.
This is the public, and this case has been going on for a couple of weeks. And if somebody wants to know, well, Bruce, why did it take you so long to solve it? Well, I was only there for like 4 days. But I can tell you that this problem was here for weeks.
How long
But it's
did it take
because
you?
of the negligence of the guy that maintains this FM transmitter. I don't have anything to do with that.
How long did the FCC?
No, nothing. Nothing.
Anything?
As a matter of fact, the gentleman that came down was so upset because he was about to lose his job. He found out the day before that we met, he was about to lose his job. So he wasn't in a very good mood.
So the FCC just?
Nothing.
No.
That's part of the problem. If you don't hold anybody accountable, what are you worried about? So don't let anybody fool you. The FAA spends a ton of money resolving other people's problems. That's for real. I had one case, I spent $500,000. Mm-hmm. We didn't get that back. So don't let anybody fool you about Uncle Sammy. We do benevolence. In Fort Pierce, we had interference that kind of bounced around 127 and 126 and 125 for a while. Drove down into town and just really got lucky, really, to be honest with you, or blessed, if you will, and found a clock inside of a guy's house. And that clock was putting out so much signal that 4 miles away at the air traffic control tower, you could hear the noise.
It had a transmitter?
That's the clock right there.
How does that transmit? Is that a receiver?
That's a receiver.
How does it transmit?
Your guess is as good as mine, unless there was some inductance going on and very little shielding. This clock radio was not Sony, I'm pretty sure.
So when you're going to these, what's your approach when you're going to these people's houses? Like you said, the other guy had the air purifier, and now this radio. I mean, are you knocking on the door saying, what are you saying?
Please. This guy didn't even have a shirt on. He was a kind of a vagrant kind of a guy, you know. There was a lot of spurious emissions in the house, just like marijuana type.
You're taking
No.
the alarm clock, man.
In this particular case, again, if it's involving a civilian, I call the FCC. They came. I also, in this case, call the police because the area was a little shady, and this guy had a little something going on. So I did call the police and the FCC because I value. I want to do my work, but I also have to use some discretion from time to time. But by the law, you should do that. That's what you should do.
Same thing for the purifier?
Yes, I did. In fact, with the purifier, that gentleman was not very nice. We went a whole week going back and forth. He was explaining to me what big government is, and and we went all down that road. And I'm like, dude, that's fine and dandy, but you know what?
Probably spend a lot
If
of
you
money.
keep it up, we will have someone down there to talk to you about turning that thing off. You're interfering with air traffic control, and that's safety of life. So it got a little heated, but the FCC did step in. They didn't step in as strong as I wanted them to, but they did. He wasn't a willing participant initially because he didn't believe that the device was causing the interference. But once he turned it off, his whole countenance changed.
So I guess scenario is basically when he doesn't know, that's one thing, but then after you tell him what he's done, now it becomes, he knows that he's interfering with it, and that's the felony side of that.
That is exactly right, and that's the key, is that documentation is very important, which goes back to something I'm glad you brought up. And I don't think we have any documented people in here, but this is why logging is so important to me, to us in Spectrum. We really need to log. Not only do we need to log for that reason, because there are cases where we may end up having to literally take someone to court, we may have to accuse someone, but we also need to log so that the bean counters in Washington are able to see what we're doing so that we can get funded. Oftentimes we shoot ourselves in the foot, we hurt ourselves by not logging. And I know I'm not talking to the right audience here, but hopefully, we're on tape, right? Hopefully someone will recognize, hopefully we'll recognize that we do need to log. And I constantly encouraging the guys out in the field, hey, let's make sure to log these events now. We gotta log these events because we gotta be able to show Washington that we are using their money and we're using it wisely and efficiently and effectively. So we're not just wasting their time. Do I enjoy playing golf after work? Of course I do. But while we're on the job, we're doing what we're supposed to do. So, but yeah, and this guy, by the way, destroyed that clock immediately after we pulled it out of the house. I really wanted to keep that one, but anyway. So, a couple of things we want to bear in mind. Some things that Paula really wants you to know. One of them is that a lot of our transmitters now that are typically at 10 watts, we're dropping down to 2.5 so that we can reuse our frequencies more often. Again, we're reusing the spectrum more. So most of our large sectors are 30 watts, and of course, our general transmissions are at 10 watts. Providing policy, technical guidance, and evaluations to the agency. That's what Spectrum is all about. We provide assistance to engineering services, TSOG, and OSCG with coverage, analysis, and resolution, especially in the case of chronic coverage problems. A lot of our RFI issues and coverage issues are coded in the National Airspace Reporting System, NAPERS, as a code 84. With air traffic experiences, when the air traffic experiences a loss of interruption in service. For an example, when an RCAG service due to interference outage would be coded as an ECOM code 84. Now the same would be true for a coverage problem. Now, coverage problems are a big issue for us as well, and Spectrum gets involved with coverage problems. And coverage problems really involve a lot of you. A lot of you help us with resolving coverage problems, you may not even realize it. Let's talk about NEMO. Not that NEMO, but this NEMO. NEMO is ZJX Sector 51, which is a sector, an oceanic sector just to the east of Jacksonville and Brunswick. Remember we talked about the Charleston rag site and the Brunswick rag site. It's Sector 51. Its frequency has no UHF pair. It is an RCAG, and again, it's an ultra-high sector from flight level 380 to 450. The service volume is 138 miles, but air traffic uses it a lot further than that. And at 45,000 feet, the RLOS is 300 miles. So we're talking about a talk down to 300 miles now. It's a very, very tall airspace. It's over 313 miles tall. It's 276 miles from Brunswick to the southeastern edge of the airspace. We're going to show that in a second. Now, we had a problem with this particular sector for 6 years. 6 years. This airspace is very critical for heavy winter traffic from the north, particularly New York, down towards the Caribbean. One site would not provide adequate coverage, so we had to have 2 sites, going back to that original. And the experience for the controllers at Jacksonville Center was that they consistently could not hear pilots' transmissions. This is the airspace called NEMO, ZJX-51. And you'll notice there's 2 RAG sites, or 2 remote communications air-to-ground sites to provide coverage, Charleston and Brunswick. This is the sector. It's very, very large. It's out over the water, which provides another problem for us because VHF transmissions over water simply do not propagate as well as over land. So the challenge now is to be able to talk to these aircraft out to these edges of this airspace. For 6 years, we had this problem. Here's another pictorial of NEMO 51 and another pictorial. This is a breakdown of the logging. Now, I don't know how much time that I have. I'm like over my time. So I don't know. I could probably go all day, but it's up to you guys. But let me provide you with a copy of the logs. If you can pass that around. And I'm going to cut to the chase just for the sake of time. This problem went back and forth, back and forth. Thankfully, this air traffic, or the local folks at the SOC desk at Jacksonville Center logged this problem pretty well. Although it was not logged with the proper coding, 84 initially, it was logged. And if you'll note, somewhere in the logging, well, you'll note on your on the paperwork that you're going to get that the official log for this problem was over 536 days. This thing was logged out for 500 days, which is right around what, a year and a third, year and a half, something like that. When you get that, I'd like for you to take a look at that. Can we turn this light back on? Okay. I want to point this out because it really just took persistence on the part of Spectrum Engineering, OES&G, and actually some of the folks who work right here in the regional office to get this thing resolved. Anybody need a copy? You're okay? I know Spectrum people don't need one. You don't? Okay. If you'll note, this problem, you note in the very, very top where it says duration, right here, the duration was 579 days and 20 hours. That's how long this thing was logged out. So you picture air traffic trying to talk to aircraft and they cannot hear them for a couple of years. Actually, it was 6 years, but this is how long the log is here. And as it turns out, all we really needed to do was come up with a different type of antenna. Once we were able to define the problem, we were able to resolve the problem. So if you look in the comments section, you notice at the very bottom of the very first page, it says, standby performs well, NCP submitted to Unity Gain antenna with folded dipole, Spectrum buying antenna. Well, Spectrum was buying an antenna because we conducted an analysis of the problem going back to this airspace. This is over 300 miles. It's very, very difficult to reach out 300 miles in the VHF spectrum. So it takes a special type of antenna to radiate that far out and be able to receive. Once we were able to define that problem, then the key was just getting the funding. Thanks to Dieter Dickpen, Derek Hamilton, and ES, the folks in ES, we were able to get the funding, but we still weren't able to buy the antenna because I don't carry a credit card. But Tanya, who's sitting right up front here, was able to get that antenna purchased for me. And those folks in Charleston were waiting for that antenna like somebody had driven up in a Ferrari. I mean, they were waiting on that antenna. When that antenna arrived, this is what it looked like on the left. You can see the folded dipole antenna to your right. And I just put a regular dipole, on the left. And I also included a regular dipole, so you just had a comparison here on the right. This is at Orlando. But notice the regular dipole, and it has a particular propagation pattern, radiation pattern, and then the folded dipole. And this is the folded dipole actually installed at Charleston. The moral of the story here is that we no longer have a problem in Sector 51.
Did the tech center get involved in that design, or was that strictly online?
Strictly from experience. We had a similar problem in Puerto Rico about 5 or 6 years ago. I purchased an antenna back then. It worked great. I looked at the problem after Jimmy Black sat down with the controllers and helped to define the problem very specifically. Once he was able to articulate that to me, I said, okay, we need this antenna, this folded dipole. And we ordered it thanks to Tanya. And once that antenna was delivered, they installed it. Hadn't heard a peep from Jacksonville Center Center. That's what we do in Spectrum. Our goal is prudent usage of a precious commodity. VHF frequencies are very scarce. How can Spectrum help you? It's 21-1 issue, unless you guys want to talk about it. Yes, no, yes, no.
You got to make it.
Okay. All right. So, in closing, Spectrum is involved with several issues, either ongoing or past. One of which is the ZMA airspace district redesign. Of course, the proposed Atlanta Hotel, the DHL hangars, runway 6, the new Charlotte runway, transmitter receiver site. The Shelbyville RCAG property issue. I don't know if any of you are aware. I don't know everybody in here and where your lines of business are, but the Shelbyville, Tennessee RAG site is about to be moved because we're being evicted, is what I'm getting at. Yes, we're being evicted, I'm sorry. The landowner doesn't like the rent. He wants more. And so, but the problem is that particular site is very critical to good coverage. So we're going to have to either negotiate or even perhaps we may have to.
Is there a VOR on this?
Not a VOR, just our RCAG. But that site is critical. And the reason why we know that is because we've already tried to move it once and it didn't work, and ZME was not happy. So the key is for us to negotiate, or what's the word? It's not condemn, but it's eminent domain. Thank you. That may be what we will have to do then. Eminent domain. We're also involved with Caribbean airspace redesign, which is much needed. Abaco Island, and also one of the islands east of St. Thomas, which escapes me right now. Of course, every year we're involved with Sun and Fun, Lakeland, the Masters in Augusta, and the Super Bowl this year. our cohorts out to the west were involved with the San Francisco Palo Alto Super Bowl. OAPM, Metroplex, DVRSM. Of course, we conduct frequency audits periodically. And we also get involved with new siting or relocation of existing facilities. Our goal is adequate radio coverage and licensed airspace. Now, this adequate coverage and licensed airspace are not necessarily synonymous. That's something that we could get into maybe in another discussion. But ultimately, it is up to air traffic to define requirements and P&R to vet those requirements, and Spectrum to analyze and further vet the requirements to see if viable based on the overall Spectrum resources. In some cases, what air traffic is asking for, we simply cannot provide. Or if we do provide, it may impact some other facility. So it's incumbent upon engineering services, Spectrum, and P&R to sit down and decide how does that shell game go. Spectrum serves as a focal point for all aviation spectrum matters. We work vigorously with engineering services, TSOG, ABN, and Tech Ops to improve all matters. We routinely alert Tech Ops, TSOG, and P&R of a need for highlight requirements. And ultimately, we strive to provide sufficient signal, but not too much, so as that we can reuse Spectrum resources in the future. I would be remiss if I didn't mention that I probably work for one of the best groups in the FAA. Paula Keogh is our communications engineer. She happens to be sitting in the back with a white jacket on. Charles Thornton, he's our radar engineer, sitting in the back. You saw the picture of him with the walk in New York with the rice. John Mormino works in New York. He handles our comm and our nav aids. Tarico Dimas is our nav aids engineer. John Love, sitting in the back with a striped shirt on. He handles our nav aids. Anuj Sinar up in New York handles radar. Ken Bostic, also our OEs and NRAs. David Harris is my colleague, or my other guy up in New York who handles radio frequency interference up where there's ice and snow. Tanisha Spruce is our AO. Stephanie's our supervisor, and Ian Atkins is our director. Thank you for all of that extra time.